question. It says, which set of angle measures could be the interior angles of a triangle? Well, remember that in a triangle, any triangle, the sum of the angles, angle A, angle B, and angle C, will always be equal to 180. Okay, so all you got to do is look for the one that adds up to 180. Obviously, the first one is not, because that's 270. The second one is way too much. 80 plus 80 plus 200, that doesn't work. The third one, 40 plus 50 is 90, plus 60 is 150, so ABC is gone. So D, 15 plus 30 plus 135, that should equal 180. 15 plus 30 is 45, and 45 plus 135 is 180. So we are good. So D is the correct answer. 2. Oops. They're asking us which number could not be a value of x. Well, remember, this goes to that triangle inequality theorem. So we have a triangle, right, like this, 12, 8, and x. So if we do that little shortcut, we know that the possible values for that third side is going to be the difference between 12 and 8, 12 minus 8, and the sum of 12 and 8. So it's going to be from 4 all the way to 20. So that third side, this x, can be any value between 4 and 20. So which one can it not be? Well, 8 is good, 9 is good, 12 is good, but 21 is outside our range. So 21 is the one that we don't want. Okay, so remember, right? So remember, any two sides, so we can write it there, but just speaking of the previous question, side A plus side B will be greater than the third side, A plus C will be greater than B, and then finally B plus C will be greater than A. So remember, any two sides must be equal to the third side, and you've got to work that for all three pairs. Okay. Quadrilateral is graphed on the coordinate plane. The vertex A is located at. So we have something that has four sides, a figure that has four sides, and one of the vertex, one of the corners of the quadrilateral is -2 and 3. So -2 plus 3, right? So we know that this is vertex A, the corner. I don't know what where the other sides are, but it's dilated. Okay, so it's A is dilated. So if A is dilated, to become A prime is going to be dilated, and we're saying that, and then let me just write the point. Right, we're taking the point, and we're saying that everything is going to be, so it's going to be 2 times -2, comma 2 times 3. Right, and that's going to be our new points. If it's going to be dilated, it's going to be -4 and 6. So notice that our A prime is going to be, instead of being 2 to the left and then 3 up, it's going to be 4 to the left. 1, 2, 3, 4, and 6 up. So A prime would be here. All right, the distance it is from the origin is what doubles. Okay. So which order pair? Oh, sorry. So we got -4, comma 6, and we want B. That's our answer. 4. Let me just bring this. There we go. Let me read the question. Okay, here are the vertices of a triangle. Make that bigger. A sequence of transformations to triangle FH results in triangle F prime, G prime, and H prime below. Which sequence transformation? I don't know. Where's the other? I don't see the other triangle. This is F prime, H prime, G prime. So let's see, where's the original? Oh, I gotta plot the original, I see. Let me make this bigger. So that's the resulting triangle. The original triangle was -4 and 2. So -4, -2, right here. That's F. And then G is 2 and 2. And H was 0 and -4. So we had this triangle that I'm drawing. So I noticed that F is in quadrant 3, now it's quadrant 2. G is in quadrant 1, is in quadrant 4 now. And then H is on the y-axis, now it's on the axis. So this went this way. The triangle went that way, rotated. So there's a rotation. And you notice that triangle is bigger, so there's also the dilation by a factor greater than 1, right? Because it increased. So anything that has these two transformations were good. So a 90-degree clockwise rotation, good. And then a dilation by a scale factor of 2. Okay, that looks good. B, it's a 90-degree counterclockwise. That's not it. C, counterclockwise. That's not it. And D, 90-degree clockwise rotation, and then dilation by a scale factor of half, which would make the triangle smaller. And actually, that's the one. Sorry, I meant to say less than 1. So that's the actual. That's what would be actually. So it did rotate 90 degrees clockwise, and then the triangle, the original triangle, got smaller by dilation factor of a half. That makes sense. So we want. Apologies for that misconception there. Whoa, where did you go? Let me bring this guy over here. Make it bigger. The triangle, what is the value of x? So we have to find the value of x. We know that 30 plus 3x minus 9. So plus that angle plus this angle here all should equal to 180. Combine like terms. 30 minus 9 is 21. 21 plus 24 is 50. So we got 3x plus 50 equals 180. Minus 50 minus 50. 21 plus 24. Sorry, this should be 45. Minus 45. We get 3x equals 135, and divide by 3, x equals 45. So our good answer is C. 6, we have a transversal, 2 lines cut by a, 2 parallel lines cut by a line here. Bring this guy over here. And we want, what do we want? We want the value of n. What's the value of n? Okay. So notice that these two lines are in between the two parallel lines, and they're diagonal from each other, so it makes them alternate interior. And if I know that they're alternate interior, I know that they are equal to each other. They have the same value. So 5n plus 4. We have variables on both sides, so let's get rid of 3n. Smaller one, right? So we get 16 equals 2n plus 4. We'll do minus 4, minus 4. 16 minus 4 is 12 equals 2n. Divide by 2, and equals 6. And we got 8. Now, before I even click on the answer, if you by any chance forget what the relationship is, there's something you can do here. I don't know if it's worth it, but you can do something like this. You can create one of these, right? And you can make up two numbers. Let's call this 30. Okay? If that's 30, everybody knows that this is 30 because they're vertical angles, which means this guy's 30 and this guy's 30. Yeah? And again, I'm picking 30. I could have picked 40, I could have picked 50, it doesn't matter. I picked 30. Now, to find the this angle right here, it's a supplement, right? So I do 180 minus 30, which makes this 150. And this 150, and we know we can go to the bottom here and make 150 and 150. Now, this is just to help you visualize what angles are congruent. So now we know that this angle and this angle are exactly congruent. They're congruent, they have the same value. So this can help you see that these two angles are equal to each other. And that's what you need to know to set up the equation. Okay. So here, now again, I'm going to pretend that I don't know if it's corresponding, alternate interior, or whatever, So I'm going to create one of these. Right. So I'm going to test. I'm taking one of these. I don't know if if they're equal to each other. So I choice A, either they're equal to each other or one angle plus the other angle equals 180. I don't know. So again, let me pick some values here. Let me make this 40. So if this is 40, everybody knows that this is 40 because they're vertical angles. So we can take those two and write 40 here and 40 here. Now, the other angle is going to be the supplement, right? So we're going to put 140 here, 140 here. And we're going to repeat here. So done. We're done. Now, these two angles are these two. And if you notice, they both have the same values, 140 and 140. So if I know they have the same value, I know they're equal to each other. So when I set up the equation, I can go 13x plus 6 equals 11x plus 30. Subtract 11x from both sides. We get 2x plus 6 equals 30. Minus 6 minus 6. 2x equals 24. Divide by 2. Divide by 2. X equals 12. Do we want? Is that what we want? What's the value of x? Yeah, x equals 12. So now if they asked us for the angle, you would come back here, replace the x with 12, multiply by 13, and add 6. But they're not asking for that. They're asking for x. So correct answer. C. Another transversal question. And what do they want here? I don't know. They want x. Find the value of y. Determine the value of answer without a degree symbol. Okay. We want the value of y. So again, we're looking at this guy here and this guy here. So again, let's set it up. So again, pick two random numbers, well, easy numbers. So let's make that 50, which makes this guy 50, this guy's 50, and this guy's 50, right? Vertical angles, and then the same angles repeat at the bottom. So and this would be 130, 130. This would be 130, and this would be 130. So now the two angles in question, this guy and this guy. So it's the 50 and the 130. Notice they're not equal to each other. So now right away it's telling me that if I add these, they're not equal to each other. So I'm not setting the equation that way. But I know they are equal to the sum of both angles are equal to 180. So I say 3y plus 28 plus y equals 180. And that's my equation. So choice A, they're equal to each other, or the sum equals 180. 3y plus y is 4y, plus 28 equals 180. Subtract 28 from both sides. And we get 4y equals 12, 7 minus 2, 152. Divide by 4, divide by 4. 4, sorry, there should be a 4. And y equals 43. No. 38. Looks like 38. More transversals. Here. This is a repeat, so I'm going to skip. Right, so now it says Mia claims that angle 3 plus 4, this angle here, plus this angle equals angle 1. Okay, that's true. Which equations below explain why Mia's claim must be true? Angle 1 plus angle 2 is equal to 90, and angle 1 plus angle 2 equals to 90. It is not. Angle 1 plus angle 2 is 180. Remember, this is 180, so A is gone. Angle B, angle 1 plus angle 2 is 180. Good. And then 3 plus 4 equals 180. And that's the only one that's true, because if you look at C, it says angle 1 plus 2 equals 90, so that's garbage. D, angle 1 plus 2 equals 180, and then it says here the angle 3 plus 4 plus 2 equals 180 as well, which is true. So we actually want D. And I misread this. Angle 3 plus 4 does not equal 180. It's 2, 3, and 4 that equals 180. Given AC, there's straight lines. Select a vertical angle paired to angle AOB. All right. Angle AOB. AOB. So we're talking about this angle right here. Who is vertical angle? Who is that one? Would be this guy right put an arrow. Angle COD, right there, right across from it. So remember, two lines like this. Actually, let me draw it better. But this guy right here would be congruent to that guy, and this guy right here would be congruent to this guy. 1, 2, they're called vertical angles. Yeah. We want here, given D and H are straight lines, okay, find the value of X. Well, these two angles are vertical angles, so if they're vertical angles, if that's 37, then the opposite angle is also 37. So this would be also 37, and we can write as a reason vertical angles. What the heck? 37. Angle angle BOD, which is this guy right here. That's two lines. And angle COA equals A because they are, what's my choice? Supplementary? No, complementary. Okay. A vertical angle pair right there. Selecting angle pair to angle AOB. So let's first locate angle AOB. Angle AOB, it's this angle right here. So whose vertical is that? Well, if you think about it, let me draw. You have to ignore the noise. So this is O, this is B, and this is A. So we're looking for the vertical angle to that angle, right? It beat this guy right here. So if you just shift this, the angle that's opposite the angle BOA is this guy right here. Right? And this guy is D, and this guy is E, so it'd be angle DOE or EOD. 15. That's the exterior angle. So, a lot of different ways to do it. If you want, you can find just so many different ways of doing this. Let's find, and let's do this in order. I mean, you don't have to. Let's do it I'm going to do it in two ways. Right? First one and second one. If you do the first one, we know that C is equal to 68 plus 3. So C is equal to 68 plus 52, right? We talked about that exterior angle. This exterior angle here is equal to the sum of the two opposite interior angles. So C equals, that's 10, 120. So this is 120. That's 120. How do we find X? Well, angle C and angle X, these are supplementary, which makes X equals 60. You could have done that. If you don't remember that, you could have taken your time and say, hey, let me find this angle first. So that missing angle is going to be, and let's call this Y, by the way. It's going to be 68 plus 52 plus angle Y equals 180. This is 120 plus Y equals 180. And you subtract 120 from each side, and you get Y equals 60. But this guy here, I'm going to erase. Now you know this is 60. If you know this is 60, you can do vertical angles, right? Because X is right, is the opposite angle of that. And you can say, hey, here's 60 as well. Not quite. Did I add this wrong? In the diagram BCD, straight line, angle MCM, angle CED. CED. Yeah? Oh, this is the angle I'm talking about. CED. So they want this one. Super easy, I guess. You can, again, focus on this triangle over here. We have two of the angles, so we can say, and let's just call this angle X. So we know that x plus 54 plus, sorry, angle, x plus 64, right? 64 plus 56 equals 180, right? So all those three angles add up to 180. So let's add up. X plus, it's again 120 equals 180, minus 120, minus 120, x equals 60. So this guy's 60. And if this angle is 60, well, this one, the opposite angle, because they're vertical angles, is also 60. So angle CED is also 60 degrees. Transversal, so I guess the topic is transversal and angles. Right, what they want here. Select a pair of corresponding angles. So let's look at our choices. Angle 1 and 5. Oops. Angle 1 and 5. Yeah, angle 1 and 5 corresponding. I mean, think about, right, if you break that and this, and if I took a scissor and cut it right here, this is angle 1 and angle 5. Are they occupying the exactly same spot? The top left-hand corner? Yes, they are. I'm just going to erase and go through the other one and show you why they're not. So angle 1 and angle 6, they're not corresponding. They're not in the same exact spot. Angle 1 and 7 are also not in the same spot. Okay, so one's the top left, one's the bottom right, so they're not corresponding. And then 1 and 8. 1 and 8 is actually alternate exterior, right? They're diagonal from each other. They're outside the two parallel lines. They are alternate exterior, not corresponding. So the only one that works out is 1 and 5, and there are ones that we want. Select 3 angles that are congruent to angle 1. All right, congruent, same value as angle 1. So let's make this a little bigger. So again, if you run into problems, one thing you could do right now is give them a value. Let's call angle 1, I don't know, 50 degrees. That's 50, angle 2 is 130, right? Because it's a supplement. So if angle 1 is 50, guess what? Angle 4 is also 50 because they're vertical. And then angle 3 is 130. And you're going to repeat the same numbers at the bottom. So 5 is 50, 6 is 130, 7 is 130, and 8 is 50. Give them back. So we want all the angles that are congruent to angle 1. So I'm going to circle. Angles that are the same value, angle 1 would be angle 4, angle 5, and angle 8. Is that what we want? Select 3 angles that are congruent to angle 1. So we want angle 4, we want angle 5, and we want angle 8. Ta-da! So give them a value. It's probably easier. Find the value of x. Okay, make this bigger. So you can start filling it. I think the easiest way, you don't even have to set an equation. You can start filling in the blanks. That's 152. This is 152 because they're vertical angles, right? So let's find the supplement. So 180 minus 52 is going to be 28. So this makes this 28 and makes this 28, right? So take these 4 and put it up here because they're the same value. This is 28 because those are 2 are corresponding. This is 152 because those 2 are corresponding. Across on the other side, this is 152 because they're vertical angles, and this is 28 because they're vertical angles. So now we want the value of x. X is 28 degrees. Not quite. Did I subtract wrong? And probably I did. No. $28 degrees. What the heck? Can you write this again? Do a circle. And just write 28. Wow. So sometimes they want. Oh, actually, yeah. I don't know why they didn't accept when I wrote the little degree. Let's see. Find the value of x. Okay, so let's make that just a little bigger. Oh no. Right, so if you have a hard time seeing this, just flip your paper over, like, turn your paper. So we want the value of x. Let's find out what the relationship between these two angles. So these two angles are called alternate exterior. Yeah, so if I draw a familiar picture, we're talking about this guy here and this guy here. They're alternate exterior. Right? So when I set up the equation, it's going to be equal to each other. Plus 9, 154 equals 2x, divide by 2, divide by 2, and x equals 72. No, x equals 77. Then let's write that here. Right, so, yeah. Angle 1 is 9x, so let me just write that so that they're saying that angle 1 is 9x. And angle 2 is 7x minus 12. What is the value of angle A? Well, what's the relationship between angle 1 and 2? They are supplementary. So 7x minus 12 plus 9x equals 180, right? These two angles are supplementary. 7x and 9x is 16x minus 12 equals 180. Plus 12 plus 12, 16x equals 192. Divide by 16, and it's gonna give me 12. X equals 12. So, but we want the value of angle A. Oh, dangerous question here. That's the value of x. So now if I come back here and plug it in, right, so this one is going to be 9 times 12. 9 times 12 is 108, so that's 108 degrees. Right? We found the value of x. So I come back here and I do the same. 7 times 12 minus 12. 7 times 12 is 84. And then minus 12 is going to give us 72. So angle 2 is 72 degrees, right? That's angle 2. So now, can you figure out angle A? Well, angle A is 72 degrees because angle 2 and angle A are corresponding. So I'm going to put a little bubble there. Okay. Increase. So let's fill in the blanks. Angle 1 right here is 235 minus 3x, okay? And angle 2 is 161 minus x. We want angle. We actually want the angle. So we got to find x and then substitute. So what's the relationship between angle 1 and 2? Like this previous problem, they are supplementary. So 235 minus 3x plus 161 minus x equals 180. Okay. Let's combine like terms. Negative 3x and minus x is negative 4x. 235 plus 161 equals 396 equals 180. We're going to subtract 396 from both sides. And we get negative 4x equals negative 216. I'm going to divide by negative 4, divide by negative 4. And that equals, so x equals 54. So we're definitely not done here. So x equals 54. Let me come back here. So here it's going to be 161 minus 54. And the value of angle 2 is going to be 107 degrees. And now A is also going to be 107 because angle 2 and angle A are, of course, no, sorry, wrong. Let me just make it better so I can use it minus 54. But this angle here is 107. Okay, Now, if that's 107, well, let me do this one. 235 minus 3 times x, or 3 times 54. And 235 minus 3 times 54 is going to give us 73, which makes sense, right? Because they're supposed to be supplementary. 107 plus 73 is 180, so we're good there. And then angle 1 and angle 8 are alternate exteriors. So this, if that's 73, angle A here is also going to be 73 degrees. Oh, good. Next. I like these questions. So they want us to find the value of the variable and then substitute and find the value of the angle. Again, these two angles are supplementary, so 2x minus 15 plus 3x plus 5 equals 180. Combine like terms, this is 5x. Negative 15 plus 5 is negative 10 equals 180 plus 10 on both sides. 5x equals 190. Divide by 5, divide by 5. X equals 38. So I'm going to actually plug it in here, this one. So 2 times 38 minus 15, it's 76 minus 15. 76 minus 15 makes it 61 degrees. So if that angle is 61, actually I should have done the other side. The other one here is going to be 119, but I'm just going to verify, so we're going to go 3 times 38 plus 5. We get 119, and if this is 119, angle A is also 119 because they're corresponding. Okay, so that's, oops. It's a quadrilateral, so the sum of the angles in a quadrilateral equal to 360, just for you to remember. Okay, so we get 102 plus 95 plus 87, and let's call this guy x plus x equals 360. Let's combine like term, 102 plus 95 plus 87 equals 284 plus x equals 360. We're going to subtract 284 from both sides. And x equals 76. So missing angle is 76 degrees. We want to use the Pythagorean theorem here, okay? Very careful in counting the units. That's the danger in this question. So what do we want? The distance between two points. Okay, so let's count. So let's first of all label this triangle. This is my A, a leg, B, another leg, and C, my hypotenuse. We're asking for C. So A, well, from here to here, and they're going by ones, so this is 1 unit, 2 units, 3 units. So A is 3. So A squared plus B squared equals C squared. So A is 3, then put a little 3 there, so it's 3 squared. Plus, and then B, from here to here is 1 unit, 2 units, 3 units, 4 units. So 4 to the second power equals 6 squared. So 3 squared is 9. 4 squared is 16 equals 6 C squared. So that's 25 equals C squared. Take the square root, and for intents and purposes, we want C equals 5. And that's our answer. Again, they are asking us to use a Pythagorean theorem for this. Not a big issue. So we want the distance from A to B. So let's draw the triangle. And we draw it like this. Okay, so let's call this A. And again, look at your scales. It's very important. Right, so this is going by ones. So we're going to count by ones. 1, 2, 3, 4, 5, 6. So that's 6. Here, 1, 2, 3, 4, 5, 6, 7, 8, and this is 8. And then this is what we want to find, our hypotenuse. All right, so A squared, B squared equals C squared, A, so 6 squared plus 8 squared equals C squared. 36 plus 64 equals C squared, so we're going to get 100. equals c squared plus the square root of both sides, and then c is, for us, 10. Find the distance between the points. Okay, so same question, but without the coordinate, right? So help yourselves and draw one. Let me just first of all drag this over here. I'm going to draw a coordinate plane. Okay, it's going to be the best one. So I know that this is -4 and 1, so let me call that -4, comma 1. And the other point is at 4, comma 16, right over here. Okay, let's call this A, and let's call this B. And this is at 4 and 16. So if I drew the triangle, right, they're asking us, hey, what is this guy? And I'll do a double line here, and I'll put a question mark. Now, this horizontal line is the difference between x values. So a squared plus b squared equals c squared. Well, first let's call this a, by the way, let's call this b. So a, this distance here, is the difference between -4 and 4. So if you are standing at -4 and you have to walk all the way to 4, how many units would that be? Well, that would be 8. Now look at your b, is the difference between the y values, 1 and 16. So if you were at 1 and you had on the first floor and you had to go all the way to the 16th floor, how many floors would you go? That would be 15. And that's how I would do this problem. Put the visual there. So we get a squared plus 15 squared equals c squared. That's 64 plus 225 equals c squared. Which gets us 289 equals c squared. Take the square root of both sides, and c equals 17. Okay, so C, our hypotenuse is 17. That's it. Sorry, that's it. That's what you want to hear, but that's it.